Hello, physics students, and welcome to the quadratic formula program. Okay, so what we're going to do is we're going to write a program that solves any quadratic using the quadratic formula. All right, so here's a typical quadratic equation. This quadratic equation has got coefficients 1, 7, and 12. So this is A. A is 1. B is 7, C is 12. Now we know that we can solve this just by factoring. So we can say that, well, factors of 12 that add up to 7 are 3 and 4. So we can write this as x plus 3 times x plus 4 equals 0. We can use the zero product property, and we can get x is equal to negative 3, or x is equal to negative 4. So you box those, and you've got your answer. Right? And this works really well for well-behaved quadratic equations. But in physics, we're going to get some pretty nasty quadratics, and we're going to want to use the quadratic formula whenever we can. And then we can just use our calculator to solve the quadratic equation for us. So, and what's the quadratic equation? You know the quadratic equation. It's x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, like so. So in order to use the quadratic formula to solve this quadratic, well, we would plug in our a, b, and c. So we would say that x is equal to negative b, that's going to be negative 7 plus or minus the square root of b squared, so 7 squared, minus 4 times a is 1, times c is 12, all divided by 2 times a, 2 times 1, like so. And this actually gives us two equations. That's what the plus or minus means. So we now have x is equal to negative 7 plus, now we've got what, 49 minus 48. That's going to be the square root of 1, which is just 1, divided by 2. Or x is equal to negative 7 minus, well, the square root of 1, which is 1, divided by 2. So we get answers of x is equal to negative 3, or x is equal to negative 4, which is what we got from factoring. Okay, so we can use factoring or we can use the quad program. It really makes no difference. The equation doesn't care how you solve it. Okay, so we're going to use our calculator to solve all quadratics. And all we have to do is plug in the coefficients a, b, and c. Once the program knows the coefficients, then it can spit out an answer. All right, so that's what the first part of this program is going to do. The first part of this program is just going to get a, b, and c from the user. So let's go to program. We have a new program that we're creating, and we're going to call this quad Q U A D, like so. Hit enter, that kicks you into programming mode, and like we always do, we're going to go to program, we're going to go to input and output, and we're going to clear the home screen. Okay, hit enter there. Now I'd like to get A, B, and C from the user. All right, so we're just going to do this the quick way. There's a little bit longer, nicer way to do this program, but we just really want to use this as a utility. We don't want other people to use our program, so we're not overly concerned about how pretty it is. So here we go. Go to program. We want input and output. We want input from the user. Okay, so we're going to prompt the user for A, and that's it. Okay, and then we're going to do prompt B, IO 2, and oopsie, went too fast there. So alpha B, And then we're going to prompt for C. So program IO to alpha C. And there we go. So now um, the the program now knows what the coefficients A, B, and C are. Oops. So as we write this program, what we have to play defense against is um, making sure that the discriminant is positive. Now the discriminant is the stuff that's under this square root. That's the b squared minus 4ac. Okay, we can't have a negative discriminant because that would give us a complex number. And for us, for right now, complex roots just don't make any sense in physics. So we want to make sure that we have a positive discriminant. Okay, so in our program, the next thing we're going to do is just calculate the discriminant. So the discriminant is b squared minus 4ac. So we're going to do alpha b squared minus 4 alpha a alpha c. And we're going to store this into another variable for the discriminant. How about alpha d for discriminant? Okay, now that we've calculated the discriminant, we have to make sure that the discriminant is positive in order for us to continue with this program. If the discriminant's not positive, then we want to tell the user that there's no real roots. So the way that we check to make sure that the discriminant is positive is we go back to program and we say if. Okay, I like to use parentheses here. So if alpha d is bigger than or equal to 0. So to get the greater than or equal to symbol, we have to go to test. So second math, we want greater than or equal to, that's number 4, 0. Okay, and did you see anything else in this menu that is going to help us here? Well, if, then, right? So then, so if d is greater than or equal to 0, then, I think I put then on the wrong line here. Let me delete that, hit enter, and then put then on the correct line. So program, control, and then number 2, then. So if d is greater than or equal to 0, then, well, then we have 2 real roots. So we want to output those roots. We can go ahead and do the quadratic formula. So for one root, that's going to be in parentheses, we want negative b, so negative alpha b plus the square root of the discriminant. The discriminant is stored in d. Close parentheses. I'm going to close one more set of parentheses, so there's my entire numerator, divided by, open parentheses, 2a, 2 times a. And that's going to give me my my first real root. So we can store that into, I don't know, how about just x? So we can do alpha x like so. Okay, now we have to calculate the other root, and we're going to do it the same way, except that this is going to be a minus sign. Okay, after you type this line, we need to store it into some other variable. I'm just going to put it into y here. So alpha y. Hit enter. So if this is true, then do this. So now we're going to go ahead and display x and y, and we're going to do that with an output statement. So we go to program, go to IO, we're going to display, so that's number 3, and we're going to do a nice message to the user. So we'll do alpha lock, so second alpha, and then quote, and we'll just say roots are, so R O O T S space, the space is the 0 key, and then, you know what, just roots, how about that? That'd be fine. and then let's close quotes, and then comma. Whoopsie, I'm still in alpha lock. That's why the J came up. So to get out of alpha lock, I just hit alpha again. So I'm going to do comma X, so alpha X, comma alpha Y. So it's going to display all of these. All right. Now, what if D is less than 0? So we need to do an else statement for that. So go back to program. Number 3 is the else. Else, we want to display a message that there are no real roots. And that's what we're going to do. So we're going to go to program. We're going to go to IO, number 3, and then alpha lock, so second alpha. And then we're going to say no real roots. So no space real, R-E-A-L, space roots, R-O-O-T-S, and then hit quotes again. All right, and then we're done with the program. So a lot of programs, we just like to end with the end command. And that does it for the quad program, except for the testing. So let's go ahead and run this a couple of times here. To run this, we want to quit the program. We want to go to program. We're going to execute 3. Okay. We know if we have 1, 7, and 12, we should get answers of -3 and -4. So that would be pretty good. So 1, 7, and 12. And it says roots, -3, -4. That's pretty good. And to thoroughly test this, we should run it again. So if you just hit enter, it'll run it again. And let's run it with where we should get a complex roots, a set of complex roots. So like 1, 2, and 5, I believe, should give us no real roots. Okay, that's it. There's your quad program. We'll see you in the next video.